Hello and welcome to EBRD's COVID-19 Resilience Framework Environmental and Social Assessment Training Programme. This is Video 3 Water Supply. My name is Stuart Hume from Environmental and Social Advisory Services, or ESAS, and I'm a social specialist. Now, for the purpose of this training video, I have two colleagues who are going to provide some input. So firstly, Mark, please introduce yourself.
Thank you, Stuart. I'm Mark McIntosh. I'm an environmental specialist with Claverton Associates, a hydrogeologist by training, and have been working on environmental matters for 25 years now, and have worked extensively with EBRD, applying their performance requirements, particularly around PR1 and PR3.
Thank you. And in relation to health and safety, I'm also joined by Alan Phillips. Alan, please introduce yourself.
Thank you, Stuart. Hi, my name's Alan, and I'm a consultant with over 20 years' experience in due diligence and monitoring assignments, including a number of assignments on behalf of EBRD.
So yes, this project focuses on water supply. And the purpose of the training video is to illustrate how EBRD's environmental and social policy and the accompanying performance requirements can be applied during an environmental and social assessment of a project within the water supply sector. Now, the example that we use is the rehabilitation and expansion of municipal water supply and treatment infrastructure. So now let's look at the project in a bit more detail. Some key facts. So the project involves the construction of new water treatment and distribution infrastructure. And this will provide more reliable and safe drinking water to an increasing number of communities. The project also aims to improve operational procedures and reducing the health and safety risks to the workforce. Now let's look at the application of EBRD's performance requirements. So PR1, Assessment and Management of Environmental and Social Risks and Impacts. Well, PR1 always applies. This project was classified as a Category B project, and the project is expected to generate significant environmental, social and health benefits from the improved reliability and safety of drinking water. The construction works required will generate environmental and social risks and impacts, and for that reason, an environmental and social assessment was completed. PR2, Labour and Working Conditions. Well, PR2 applies because the project involves the use of a workforce and multiple primary suppliers to provide a range of goods and services. And so due to the number of different companies involved, contractor management is going to be a key issue. Now, in relation to the application of PR3, resource efficiency and pollution prevention and control, Mark, please tell us why PR3 applies to this project.
The prime reason PR3 applies is because the project's going to be abstracting a significant amount of groundwater. And under PR3, we need to ensure that that is abstracted in a sustainable manner. So also other resources which will be used include the fuel for the pumping and chemicals for water treatment. From the pollution prevention and control aspect, we'll be looking at how they manage all the treatment chemicals and discharges from the project to ensure there isn't any impact on the environment.
Thank you. So in relation to PR4, Health, Safety and Security, Alan, please tell us why PR4 also applies to this project.
PR4 is always going to apply to a project that involves an element of construction, especially in the case of this project where there are notable excavations and confined space entry requirements, and also chlorine and disinfectant systems being installed and used.
Thank you. And so moving on to PR5, Land Acquisition, Restrictions on Land Use and Involuntary Resettlement. Well, PR5 also applies to this project because additional land will be required for the expansion of the existing infrastructure, and that will involve temporary restrictions in access to land by land users. PR6 applies: biodiversity conservation and sustainable management of living natural resources. PR6 applies due to the requirement for the project to clear land which is currently vegetated. Now, PR7 Indigenous peoples, well, that doesn't apply because there are no people in the project area that meet the PR7 applicability criteria. PR8 Cultural Heritage. Well, PR8 does apply because the project involves significant excavations and earth movements, and these have the potential to damage artifacts and other archaeological resources that may be present below the ground, and so a chance find procedure will be required. Now, in relation to PR10, information disclosure and stakeholder engagement, well, PR10 always applies, and in this project, a comprehensive public disclosure and consultation process was required. There was significant stakeholder interest in the project as the current water supply infrastructure is inadequate. So we've now introduced the project, and what we will do is we will explore the application of PR3 and PR4 in some more detail. So as I said earlier, the existing water supply and treatment infrastructure is unsafe and it requires rehabilitation, it requires improvement. Only 50% of the local population has access to safe and reliable water supplies. And there is a high risk of microbial contamination of water due to the low reliability of disinfection systems. And so now let's move on to task 1, review of existing documentation. So in relation to the information requested from the client, Mark, please take us through the information required for PR3, resource efficiency and pollution prevention and control.
Thank you, Stuart. The information we've requested under PR3 is really information which is going to give us a fuller picture of the project and its broader area of impact. And we want to understand how well the company who's applying for this project is currently managing the portfolio that they have and the impacts they have. So, for example, in this list, we include some of the key aspects which we will be considering under PR3. How well are they monitoring their resources? So therefore, we've asked for the annual resource use. Water is the primary resource, but they're also using fuels for the pumping stations, chemicals, and requesting their information on what permits and authorizations they have for the water abstraction and the discharges from their treatment plants. We're asking for the borehole distribution map and the design details of the boreholes, such as their pump depth and their abstraction rates and durations, so we can start to appreciate where the water is coming from and from what depths and how well it's being monitored. We're also looking for information on the design of their treatment infrastructure, and so we can understand what the likely discharges are from that infrastructure. We'll ask about their waste inventory to understand how well they're monitoring and managing waste, and if they really are tracking it closely and understanding how much can be recycled or reused. We're also asking for information on what their ongoing monitoring activities are. How well are they monitoring their abstraction rates, the water they're treating, the water quality, how good are their records, and the groundwater elevations in the boreholes, and how good are their pump maintenance records, so we can appreciate and look back and cross-reference to the environmental management systems and procedures which might be in the company. These are just some examples of documentation deep dive into their systems to both appreciate how PR3 is being managed, but also look at their broader environmental and social management systems.
Thank you. And so, Alan, in relation to PR4, health, safety and security, Please take us through the types of documentation that was requested from the client for this particular PR.
The information we requested is designed to allow us to understand the extent to which the project understand the risks and hazard associated with delivery. Additionally, we wanted to understand the controls and how prepared they are to manage these hazards and risks. To this end, we requested the health, safety and security policies and procedures, their incident and occupational disease statistics and investigation reports to understand historic performance. We also requested a health and safety audit log to understand how good they are at diagnosing their own issues. We also asked for the induction training pack so we can get an idea of how prepared the workers are. Additionally, the permit to work system was requested, including procedures for confined space entry and rescue, excavation, loan and remote working. And finally, we also asked for their emergency preparedness and response plan.
Thank you. So that's task one, the review of existing documentation and the different types of documents that were requested from the client. So moving on to task two, the site visits and discussions. So in relation to PR3, Mark, take us through, please, the key findings of the site visit.
Thank you, Stuart. So following our review of the documentation, we already had a lot of questions in our minds as to things we wanted to close out through the site visit. The site visit was an opportunity both to see the infrastructure and systems on the ground, to look at how they implemented their management systems, understand the quality and capacity within their team. We found with relation to the environmental management that actually they had a very incomplete environmental and social management system in operations. They also did not have a dedicated environmental and social department. Environmental and social aspects were covered by a disparate number of people, with no one with overall responsibility. This was manifest in the fact that the client didn't have a record of permit consents. It didn't have a database which was in any way complete or up to date. And we could already see that within that, what we could read in the database, some of those permits and consents, which were required under national legislation, had expired or were invalid, indicating there was a lack of tracking of their consents, the reapplication for new abstraction consents, and generally poor management of the environmental and social aspects of the projects. We're also looking at, particularly at PR3, with the resource and sustainability. We noted that the project's going to increase groundwater abstraction to 20,000 cubic meters per day. But it does avoid abstraction from the river. However, the increase in demand is a major trigger for PR3 reporting, and therefore requires detailed investigation to assess the sustainability of that supply. We could also see, based on the limited information, that the existing water supply network, which we knew was old, had many leaks, and there were few shut-off valves which could be used for either containing leakage areas or making repairs. The groundwater elevation monitoring the boreholes was also found to be inadequate, with limited monitoring being done. And there, as a consequence, the abstraction volumes were not being accurately recorded, which has a knock-on effect to them not being able to manage the aquifers from which they're abstracting in a sustainable manner. There was an inadequate assessment of the sustainability of additional groundwater abstractions which would be needed, or assessment of what impacts that abstraction might have on other users in the areas, for example, local independent community wells, personal wells, agricultural wells, and the like. We also, through walking through the sites, it was quite plain and clear that there were many issues around contamination and pollution risks. There was poor management of chemicals, which potentially at risk to the general environment, but also to the project's water supply system by potentially contaminating the water wells themselves. We also found that there was insufficient monitoring of an analysis of the water which was been abstracted, or of the water which was being put into supply. And therefore there was no guarantee that the water quality which was being used for potable water supply met the required standards. We also found the waste management storage arrangements were poorly managed. They were actually found to be near the wells in an uncontained state, with drums which were damaged and leaking.
And so now moving on to PR4, health, safety and security. Please take us through the key findings of the site visit.
Thank you, Stuart. As you can see from the photos, it was obvious when we arrived on site that safety culture is poor. Personal protective equipment is not routinely used, and tools are often homemade and in poor condition. There is no formal process of ongoing risk assessment, and there is no documented occupational health and safety management system aligned to a recognized standard, such as that of ISO 45001. The training of workers includes a basic induction with no refresher training. Workers do not understand what constitutes good international practice. High-risk activities and competent persons and authorized persons are not identified, and there is generally a lack of supervision and inspection of construction works. Compliance with requirements is left to the responsibility of subcontractors without any support from the client. With regard to high-risk activities and permit to work, the project has not developed safety procedures or a permit to work system for these high-risk activities. This includes undertaking works on chemical dosing systems or work on energized systems. The only emergency procedure is for use of the chlorine disinfection units. A key risk identified during the visit were the control of risks associated with work in confined spaces. Our observations included the fact that ventilation is poor, and where mechanical ventilation is provided to the confined space, the ducting is often damaged and leaking, with no evidence of inspection and maintenance. Gas test and analysis is not always undertaken before entering a confined space. And there is no control over who can access a confined space or system to record who is currently working within that confined space. Furthermore, breathing apparatus is not available. Workers are just issued with dust masks. And there is no constant supervision from outside of the confined space. Furthermore, no specialist training is provided for those working in the confined space, or indeed is there any kind of health screening for those people who are working in this potentially hazardous and difficult to escape from environment. Additionally, there is no rescue equipment to effect a rescue, such as winches, harnesses, or a stretcher. And there is a lack of a dedicated communication system between those working within and outside of the confined space. Instead, workers are relying on verbal commands. Work being undertaken within the confined space outside of normal hours has no additional controls or supervision. At one point, a gantry crane is used to enter a large confined space, but there is no additional means of access and escape should the gantry crane malfunction. One of the key problems is that the project hasn't defined what constitutes a confined space. It's important for workers to clearly understand this. For example, the site has a number of deep excavations. These could be confined spaces, especially considering chlorine is used on site, and chlorine is 2.5 times heavier than air and may settle in a trench. We also identified issues with trenching and excavations. We made the following observations during the site visit. The excavations appear unstable, and there is a lack of shoring or benching to reduce the risk of trench collapse. Additionally, trenching is being undertaken during the rainy season, increasing problems with trench stability. As you can see from the left-hand image, the trenches are deep and there are workers working within them. They also contain water. This work could have been undertaken by a machine outside of the trench, reducing the risk in accordance with the hierarchy of hazard control. It's obvious from the photos as well that there is no suitable edge protection or warning provided for the excavations. Two means of access and escape is not always provided to deep excavations. Furthermore, where access is provided, it is of poor quality, with homemade ladders, no handrails, loose stones and trip hazards, and other problems preventing safe access. Some of the excavations are deep in slippery clay with no means escape, and there is no rescue equipment, such as a buoy or a line. Some of the trenching is also being undertaken within the community. These sites are not fenced, and the public can access the works. With regard to lifting operations and equipment, the project requires extensive lifting of heavy loads, such as concrete culverts, manhole chambers, and ring beams. We noted the following concerns during the site visit. Lifting operations are not supervised by a trained, competent signaller or banksman, also known as a spotter. Heavy suspended loads are being lifted over the heads of workers, as you can see in the left-hand photo. This risk should be eliminated, or where unavoidable, suitable protection should be put in place. For example, the installation of a crash deck. Loads are not secured by qualified and competent riggers and slingers, and suitable slings are not always used. For example, you can see from the middle photo that a piece of reinforcement bar has been used as an impromptu sling for a concrete block. Additionally, in the top right-hand corner, the IBC cage has been used as a lifting anchor. Where slings are provided, they are often damaged, as you can see in the bottom right-hand photo, and they have not been effectively quarantined. For example, storing them securely or possibly cutting the lifting eye to prevent reuse. Then there is also no evidence that equipment is periodically inspected and tested. For example, the use of a color coding system would allow workers to easily identify which equipment has been inspected and is therefore safe to use.
Thanks, Alan. And so, Mark, please take us through the key findings from Task 3, analysis and reporting using the EBRD format.
Thanks, Stuart. As was clear from the earlier data review and the site visits, there was a need for a serious upgrade here into the whole management system, both its procedures, its plans, and also the overarching controls and policies. So within our environmental social action plan, the first item was in relation to ensuring there was an update to their management system procedures, including all the additional monitoring of abstraction, treatment, and supply activities which we'd identified during the data review and the site visit. Importantly for this project, they needed to develop a contractor management plan. The project will involve numerous contractors, and they need to be compliant with the overall management system of the company once it had been upgraded. There was obviously a lack of control on their permits and consents, such that they were out of consent, they did not have permits to abstract, and therefore were non-compliant with national legislation. This required them to develop a permits and consent register so that they were tracking it and then rectifying all the lapsed consents and reapplying where needed. They needed to implement a pipe repair program so that they reduced the number of leaks in the system and therefore reduced the amount of water they were needing to abstract and improve their resource efficiency with regard to the sustainability of the groundwater supply they would be using. A key issue we identified was the lack of a quality laboratory, which would enable them to both monitor the quality of the water they were abstracting, and so therefore they understood how they needed to treat the water in their treatment system, but also the quality of the water they were putting into supply. The need for a new laboratory with a good QA/QC procedure and qualified personnel with the appropriate roles and responsibilities, training, and also ensuring there was a procedure to regularly calibrate the equipment was a key finding which was included in our ESAP. A key finding of the ESAP was the need to assess the sustainability of the proposed water abstraction. This could be broken down into three elements. Firstly, an analysis of the hydrogeological parameters of the aquifers they were abstracting from. Secondly, looking at the pumping and required monitoring of those aquifers to ensure the sustainability of the supply. And thirdly, to use a hydrological model to assess broader impacts to other users in the area.
Thank you, Mark. And so, Alan, in relation to PR4, please take us through the key findings.
Well, it was obvious that the project needs to develop an occupational health and safety component to their management system to improve safety culture and risk control. The system must include a clear definition of roles and responsibilities for all organisations, from the client to subcontractors. It also needs a risk assessment process, risk register and controls based on the hierarchy of hazard control, which are then incorporated into working procedures. Training and competency requirements, including requirements for authorised and competent persons, needs to be understood and training provided. The emergency preparedness and response plan needs to be extended to cover all likely scenarios, not just in relation to chlorine use. Monitoring processes need to be defined, including the process of audit and inspection. And reporting protocols need to be established. This includes reporting to regulatory authorities, communities, as well as EBRD. And a management of change procedure must be developed and implemented. Management of change procedures are vital to ensure risks don't enter unexpectedly or hazards get missed. And the system must include a formal review and update process. In relation to high-risk activities, the project needs to develop risk control procedures, such as a permit-to-work system for handling of liquid chlorine and work in confined spaces, as well as any other high-risk activities that could occur on site. And concerning lifting, the project needs to develop a lifting procedure, which includes requirements for supervision by a qualified banksman or signaller, which prohibits lifting suspended loads over workers, or if unavoidable, adds additional safety controls based on the hierarchy of hazard control. It needs to specify the controls required for different size loads, including the maximum allowable wind speed. And it needs to detail the inspection and certification requirements for all lifting equipment used on site, including those bought on site by contractors. It also needs to require the use of qualified competent riggers to sling loads. And it needs to identify any additional controls for lifting operations taking place in areas accessible to the public. Furthermore, it should specify some kind of system that allows workers to easily identify which lifting equipment has a valid test certificate and is therefore certified and safe for use, such as a colour coding system. With regard to trenching and excavations, the project needs to develop a trenching and excavation procedure, which details the minimum depth at which trench shoring or benching is required, which prohibits workers to enter trenches, or if this is unavoidable, adds additional safety controls, again, based upon the hierarchy of hazard control and informed by risk assessment. Furthermore, the procedure needs to state the requirements for edge protection, including signs, barriers, or rescue buoys and lines for water-filled excavations. It also needs to define excavation access requirements, ensuring there are always two paths of access and escape. It needs to also include requirements for inspections before the start of every shift, and especially after any event which might change the nature of that excavation, such as a period of heavy rainfall. And it needs to include additional controls for excavation operations taking place in public areas to reduce risk community safety. This could include signage, barriers, community safety awareness raising or meetings, or generally other forms of engagement.
And so let's now close by looking again at the application of the PRs to the project. Now, we have, of course, looked in detail on the application of PR3 and 4 in this case study. But if we look at the table, we can see that all of the PRs apply, with the single exception of PR7, Indigenous peoples. So, for example, in relation to PR2, we would expect a robust set of human resources, policies and procedures in relation to management of the workforce and also management of contractors involved in the project. And of course, in relation to PR8, cultural heritage, we would expect a chance find procedure to be in place. So that now concludes video 3 on water supply. I hope you have enjoyed the training video, and please refer to the additional resources that are available on the website. Thank you very much.